speaking of load, so a really high HVAC load will cause a spike in electrical load, likely because your equipment is going to be staging on at its hottest or at its biggest. And so let's talk about these examples of demand reductions. It's a part of the regulations required. Cultivators and businesses are required to look at options for this. So what are some options that are out there that are realistic?
Thank you, Gretchen. So a big issue in your planning phase is understanding shift work. Will all of your rooms be on for a 12-hour cycle? And will then all of your rooms conversely be off for a 12-hour cycle, or 8 and, or 6, in the veg cycle? You'll have different timings. But one major method of load reduction is to flip your grow cycles. I mean, it works at very, very small scale when you have, small operations, but it works massively when you have a large scale, but it has to be coordinated with the municipality. The town needs to know, usually in your host community agreements and in your municipal entitlements phase, you're having conversations with the town administrators and talking about when will people be working in this facility. So it's important to start that conversation early with the town and establish the working hours that your facility will be open, and understand, is there any pushback from the community to having 3 shifts working in this building or to having 2 shifts? Because the last thing you want to do is change that once you get open. We don't want to design it one way and then have someone operate it in a different method. So that's another example. So to reduce demand is flipping your cycles. If we like to stick with even numbered rooms. We don't like to design buildings with 3 grow rooms. If at all possible, it's better to have 4 or 2, so that you could flip 1 on, 1 off.
To sort of flatten that load, and you never have huge peaks.
I'm sorry, Gretchen, I didn't hear that.
So by staging those 2 opposite from each other, you essentially flatten the load so that there's never a 4-room peak, correct?
Correct. So we are able to actually transfer the cooling load from room A over to room B as that shift occurs. If both of those rooms are on, you could see immediately that your cooling load is doubled, because both of your rooms are on at one time. They both have to be cooled. That means you need a cooling capacity equal to both of those rooms being on. Same facility, same production output per year, run half your, in a 24-hour day, run half the rooms on, half the rooms off. You've just reduced your cooling load by half.